My name is Srinanda Zavdekar, and along with my colleague, Dr. Jim Chow, we'll be presenting one of the very exciting and interesting technologies and features that we have been working on for a while now. So before we get into the technical stuff, I'm required to go over some legal stuff about the presentation. This is basically to say that the feature that we are talking about right now is currently under development. There is no commitment on the part of VMware to make this available in any generally available release. Obviously, the architecture and various things that we talk about the feature are as they stand today. They could change in the future. And obviously, because everything is still under the works, we don't really know about the pricing and packaging information about the feature. All right, so let's get our hands dirty. The agenda for the talk, we'll start off by talking about the vSphere availability portfolio, a wide range of products and features that are already a part of vSphere, and few things that we do to make sure that your VMs are up and running most of the time. We'll talk specifically about why fault tolerance is important and necessary and how it is something that can definitely benefit workloads. We'll talk about multiprocessor fault tolerance details. Essentially, what we'll be doing is we'll distinguish between uniprocessor fault tolerance versus multiprocessor fault tolerance. We'll look at the architectures of these two products or features, and we'll see how they are different. We have a live demo for you, and it's going to be something interesting. And followed by that, we'll have some more data about the performance numbers, again, as of what the product is today. And finally, we'll have some time for question and answers. I'm going to start off by saying something obvious, something like a universal truth. And that is, inside of your data centers, disasters happen. No matter how hard you try, you could have like the best hardware in the world, the best software managing your data center, the most dedicated system administrators keeping a very close eye on every single thing that's happening in the data center. But no matter what you do, disasters will happen. Servers will fail, DIMMs will go down, networks stop running, disks will crash. In some unfortunate situations, if you could have burnt racks, but something or the other will happen and workloads will stop running. We were trying to look for data about server failures and stuff like that, and we found something that was published by Google. They mentioned that in their data centers, they see as many as 4% of servers fail in some situations. There are times when they see 5% of disk drives crash. They even see situations where they have entire racks go down, which take down with them multiple machines. And for these server machines to be back up online, there are times when they see as much as 6 hours of downtime. So the question really is, in such situations, what can you do so that you can mitigate the problem? Or in general, what is it that you can do so that you can have the best availability possible and your workloads and virtual machines are always up and running? VMware has been looking at this problem for a while now. And at various different levels, in various different products and features, VMware has been trying to solve this problem of availability. So we have a wide range of products, starting from individual components, like we protect against NIC network cards going down or storage adapters going down, right up to the site recovery manager, where your entire site is replicated between geographies. And if site A goes down, then you can move over to site B, and things can continue to be up and running. We won't go into the details of all of these products right now. We'll focus on one really unique, really special product that we have in this, and that is fault tolerance. The reason I say that this is really unique and special is because this is the only feature that offers you continuous availability. We are choosing our words very carefully here. Continuous availability is different from high availability. We've all known about high availability solutions that are offered even by VMware and by other vendors at various levels, including application level high availability. Essentially, what happens in HA is that someone keeps an eye on your workload. And if they see that the workload is not running, they will restart the workload. But you do see that there is a small window of time when your workload goes down, the HA application detects that it is down, and it will restart it. So there is small amount of downtime, and that downtime can have other repercussions, which are something that you wouldn't want. Continuous availability essentially guarantees you zero downtime. And the way this is done is that you always have 2 replicas of the entire workload up and running always. The challenge here is to make sure that these 2 replicas are always kept in sync. And therefore, what happens is, because you have 2 replicas, if one of them goes down, the other one can go live instantaneously, and that can give you zero downtime. apart from zero downtime, this also guarantees you zero data loss. So as a part of making sure these two replicas are always up and running and are always in the exact same state, one of the things that you do is you will have both these replicas operating on the exact same data. So you could have the primary, let's say, working on a set of data or maybe in the middle of a transaction. But when it goes down, the secondary takes over and it has the exact same data that the primary had, and therefore there is zero data loss. If the primary was in the middle of a transaction, the secondary would go live, complete the transaction, and then move on. There is no loss of TCP connections. Now, the advantage of doing these things is that the failover times are so small that TCP wouldn't detect that a network failure or that a FT failover has happened, and therefore it wouldn't even know that anything has changed. So if you have client machines or client applications connected to an FT-protected server, your FT failover happens, so primary goes down, secondary goes live, but your clients don't even know anything. Obviously, in order to make sure these things also happen is we have both these replicas have the exact same IP address, the same host name and stuff like that. So they have the same identity on the network. And then FT is completely transparent to guest software. So again, that's one of the very interesting and important parts of this. Because we are doing things at the level of the hypervisor, the unit at which we are operating is that of a virtual machine. So it doesn't really matter what is it that is running inside the virtual machine. So protecting a database server running on Linux is just as easy as protecting an Exchange server running on Windows, and that is just as easy as, say, protecting a custom-built application running on Solaris or any other OS for that matter. There is no dependency on any guest OS or applications. For us, everything is a virtual machine, and protecting a virtual machine any virtual machine is just as easy. Also, there is no application-specific management and learning that is involved. So one of the things that we've known over the years is clustering solutions like MSCS or any other solutions require you to understand how things work. You need to know, there's a lot of learning and management involved. You need to know how to deploy it, how to make it work with other applications. If things change or newer releases happen, you need to know what are the newer features that were added and how you need to make changes so that you can deploy them successfully. In the case of FT, you have a virtual machine. You right-click on the virtual machine, and few clicks later, you have them FT protected. There is no management or learning of any sort that is required. It's very difficult to go wrong when you're configuring FT for a virtual machine. So some of you might know that VMware already has a product for fault tolerance out in the market. In fact, we released our first product in 2009, and it was called vSphere Fault Tolerance in vSphere 4.0. Over the next few years, we added more features to it. We added support for newer processors that were released in the market. However, this feature had one major limitation, and that was you could only protect a virtual machine with fault tolerance if it had one vCPU. Now, this was a very important limitation because there are so many workloads that require you to have multiple vCPUs. And then in those situations, you couldn't turn on FT. So this started begging the question, is FT for multiprocessor VMs even possible? And let me tell you, this is an impressively hard problem. There is a lot of research happening around this by other companies. There is a lot of research happening in academia trying to solve the problem of multiprocessor FT. And VMware has been also making a concerted effort to find an approach for doing this. We believe we have reached a key milestone, and this is the milestone we are here to share with all of you today. So let's take a quick look at what the uniprocessor FT solution was and what is the multiprocessor FT that we are talking about right now. What does it look like? What are the differences? So as I said, in the case of fault tolerance, you have two replicas of the virtual machine always up and running. So in this case here, we have one virtual machine running on an Esx host. Let's call that the primary. You have another virtual machine running on a second Esx host. That's called the secondary. In the case of uniprocessor FT, we used a technology called Lockstep. This is the technology which made sure that these two virtual machines are always kept in the exact same state. So implementing this technology, you had these two virtual machines in the same state. If the primary went down, the secondary could go live because both of them were implementing the Lockstep technology. Now, in order to keep these two virtual machines in sync always, there had to be a lot of data that had to be sent between these two virtual machines. This happened over a network connection between these two Esx hosts, and we called the network connection between these two called the FT logging network. In the uniprocessor FT case, we recommended that the FT logging network should have a bandwidth of 1 gigabits per second. The other interesting design decision that was taken at that time was the use of shared VMDKs. So you not only had two virtual machines in the same state, but they were both using the exact same disks. Now, the advantage of having shared VMDKs is that if the primary goes down and the secondary is going live, the secondary obviously sees the exact same disk and the disk in the exact same state that the primary was seeing when it died. And the other part here is there were already other features of VMware like VMware HA or vMotion which required the use of shared storage. So we were building on top of that. However, using the vLockstep technology and this entire architecture for solving the problem of multiprocessor FT was kind of becoming a little tedious. So instead of going that route and trying to make it happen really, we just took a step back and decided to go back to a clean slate. And we just said, okay, the problem is simple. I can have a virtual machine. The virtual machine can have any number of vCPUs. It can be doing anything. It can be running any guest software, whatever. What can I do to make sure that this is protected by FT? It has to be up and running always, 100% of the time. So after going through a lot of different options and brainstorming about different ideas and implementing some of them, we finally came up with a new protocol for doing this thing. Let's call it the SMP FT protocol for now. So basically, instead of vLockstep, now we have a new protocol for making sure that you can have two virtual machines always in the exact same state. After running a few experiments using the SMP FT protocol, we realized that in order to get the best performance, the FT logging network that you had between the primary and the secondary Esx host would now be a 10 gigabit Ethernet connection, so that would give you the best performance. Also, instead of using shared disks between the two virtual machines, we now just decided that let these two virtual machines be two completely separate entities. So let them have their own individual VMDK files. Now, the advantage, as you can imagine in this case, is you could have, let's say, the primary virtual machine by itself is running, but let's say it loses access to its storage at some point in time. And in that case, you could imagine doing an FT failover and make the secondary virtual machine go live, and assuming that it has access to its own storage, it can just continue to run, and things will be just as good as you could imagine. So you can now have some level of storage protection as well. I'm not going to go into all the details of the SMP FT protocol and the details of how we implement it and so on. But as they say, the proof of the pudding is in eating. So let me hand over to Jim, who will tell you about the pudding.
All right. Thank you very much, Renan. As you said, my name is Jim Chow, and apparently I'm here for the pudding. Okay, so before we begin, I want to talk about some preliminaries. But what I want to go over first as we look at FT in practice is some concepts that are important to know if you're about to use FT. So maybe one day you find yourself at the steering wheel of multiprocessor FT, and you're going to need to know a few things. The first thing you're going to want to know is how to turn it on. And an important thing to keep in mind when you turn on FT is that you're actually creating, let's see if I could get the clicker working, you're creating two VMs. One VM is the VM that you already have. It's your workload. It's installed all your software. And when you turn on FT, you create a second VM, which we call the secondary VM, and the first one being your primary. Now, these are actually two identical VMs. You create a new one when you enable FT, and this new one is identical in almost every way. It has the same amount of VRAM, the same number of vCPUs, vNICs, et cetera, et cetera. It has one or a few differences, which is that each VM owns a complete set of VM files. So it's a completely independent, completely new VM that you're creating. It's an important concept to remember. In particular, they'll both have their own separate VMDKs. And again, when you create these two VMs, they have these roles. We call them primary and secondary. The primary one's actually running your workload. The secondary one is acting as a replica, providing a backup of the state. Now, the roles of the two VMs is actually fluid during the lifetime of fault tolerance. So the primary, which one is primary and which one's acting as a secondary, can actually switch over time. So that's the first thing you should keep in mind. The second thing that's important to know is a little bit about data storage. When you create a new VM using the vSphere client, the default option when you create that VM is to store all the files associated with that VM in a single data store. And that's just the default out-of-the-box behavior. Now, if you want, you can certainly get more advanced. You can take out the individual components of a VM, the VMDKs, et cetera, and split them off across different data stores. Now, there could be very good reasons for doing that. For example, if you're running a database workload, they might recommend best practices to put the OS disk, for example, on a separate data store than your database files. You could get some performance that way. There could be some advantages for doing that. Now, likewise, when you create this FT VM, you're creating a second VM. Now, by default, you can imagine stuffing everything on the same data store, both your primary and secondary VM. And that includes all the VMDKs, et cetera. Similarly, analogously with the normal case, you can also spread out all this data across multiple data stores. So you can take every component of each VM and sort of pick and choose and place it on a different data store should you desire. Now, there is one data store, however, that you cannot do this for, and that is, I should say, before I get into that, there could be a very good reason for doing this, over and beyond the actual performance benefits that we were talking about earlier. And that is, if some of the data stores were to go down, if you spread it out in this fashion, any living data stores could be used to, for example, run a secondary VM. So there's some tolerance over storage failures that way if you did that. So it's beyond sort of a performance metric. Now, I should say, you can spread things out, but there is one data store that we do require to be in common between the two VMs. And that data store is one we call the Tiebreak data store. So the idea there is pretty simple. We have this green line here, as Srinan was mentioning. This is something we call the FT logging network. It's the communication channel between the two VMs. And actually, that network serves as the sort of synchronization protocol, the replication, sort of making sure the two VMs are in lockstep. And when that channel goes down, the two VMs are now incommunicado. They need to make a decision. They have to come to a consensus about who should keep running. This is the split brain problem. And in that situation, they need some mode of communication to arrive at a consensus about which VM should run. We provide a secondary mode of communication through what we call the Tiebreak data store. That's our backup line of communication. So should a network partition or one of the hosts go down, we rely on that data store to decide which VM should continue running the workload. And so this data store ensures that we only have one running copy of the VM at any given time, even in the face of a network failure. OK, so that's some preliminaries. Let's see how you would actually use this. So this is the Vsphere Web Client. And we've got our list of VMs here. And if we want to enable FT, we sort of go down to this menu, submenu here. We turn on fault tolerance. It's in the lower right-hand corner there. And what that'll do is that'll bring up this wizard here. And it'll take us through the process, going through many of the concepts I just laid out. So the first thing it's going to ask us to do is what we call the initial placement of the secondary. So we're creating a new VM, secondary VM. You don't want to put on the same host as your primary VM because you're providing a fault tolerance here. So you got to choose a new host to run it on. And so this is what we're calling the initial placement of the secondary. There's the host that will run your secondary VM. Now, we'll take questions at the end, just for logistical reasons. So it's important to note that you're not tied to this host that you choose, the Esx host in your cluster. Pretty much any host in your cluster is suitable to be run as a secondary to a VM that you have. In fact, if this host were to go down because if it were to get a power failure or something like that, vSphere itself takes complete responsibility for choosing a new host in your cluster and reestablishing protection by running the secondary on that host. So all of the magic that happens for maintaining the FT connection and finding a host to run your secondary on, that's all taken care of automatically by vSphere. This is just an initial placement, sort of a hint if you had a preference there. So you're not tied to it. Now, once you've made that selection, there are some checks that we do to ensure that it's a compatible host. And by that, I should say that pretty much any host in your cluster should be suitable to run your secondary, although we do require that you not mix and match computer architecture. So if you're running an Intel host, you can't have a secondary that's an AMD host. More generally, what we actually require in this prototype is that the two hosts be vMotion compatible. And as long as they're vMotion compatible, they can act in this relationship where they're acting as replicas for one another. And that last restriction actually subsumes the first, because Intel and AMD hosts are not vMotion compatible, as it turns out. And I should also note that this is an improvement on the FT feature as it exists in vSphere today, which has much more strict requirements over and beyond vMotion compatibility for which hosts can be paired in an FT relationship. So this is what we have in the current prototype. So we're going to choose that host, and then what we're brought to is a list of the various files that comprise that VM. So in this particular case, we've got a configuration file. We have this Tiebreak data store that we've already talked about, and we have the various VMDKs for that VM. Now, by default, we're just going to shove all that on a single data store. Of course, if you don't want to do that, that's certainly valid, and it's as simple as going through this menu and clicking through each component of the VM and deciding which data store you'd like to put that piece of data. And you can just click Browse and go through a list of data stores and choose it to your heart's delight. Now, once you've gone through selecting all these data stores, will bring you to the last part of the wizard. It's just confirmation about your selections. And once you've done that, you're all done. You're ready to go. You've turned on FT. You're ready to rock and roll. So I've already done this on a VM back in Palo Alto, which I'd like to show you. But before that, I want to tell you a little bit about the demo. So one of the things we had to do is choose a workload to show you. And one workload people come to us not infrequently about is a workload called the Vcenter Server. So you're probably all familiar with it. I don't have to describe it to you, but it's sort of the central management server for your vSphere installation. Actually, the reason people come to us is because ensuring continuous availability for this workload is actually not a trivial thing to do. And it's very important, too. Now, we've rigorously architected vSphere to ensure that if your vCenter server goes down, your VMs continue running. Your clients can use their VMs. Nobody experiences downtime. Everything is hunky-dory. Now, at the same time, it's not good if the vCenter server goes down. There are certainly some operations that require the vCenter. If you want to do a migration or something like that, you need to have this thing running. And when it goes down, you're going to experience some lack of service there. So people want continuous availability. And as it turns out, Multiprocessor FT makes it a pretty simple thing to do. And it's actually a very natural fit for this workload. And the reason is the vCenter is actually easily virtualizable. And by that, I mean all the dependencies and pieces of software that it depends on can easily be packaged into a single VM. And once you've done that, you can then take that and then protect it with Multiprocessor FT. And another thing I should say about this workload is that vCenter itself requires a multiprocessor system to run on, and as do a lot of workloads. So there's a natural fit. We wanted to show it to you. So the first thing I want to go through is a failover. And so the idea here is that I'm going to log in with, so you've got your data center. It's running vSphere. I'm going to log in with the Vsphere Web Client. It's going to talk HTTPS over into our data center there. Now I've got vCenter virtualized inside a VM, so it's going to talk to a VM there. And then I'm going to take down a server in that data center, and that server is going to go down. And as that happens, that server was running our vCenter VM, and so the VM goes down. And then the magic of FT will ensure that the secondary host which was running the replica, can take over. It switches the control over to that new VM. That new VM continues to respond to requests without logging out the client, without issuing any disconnections, and that makes our user pretty happy. So let's switch over and see how that works in practice. I'm going to log in here, screensaver. I'm going to switch over here to our live streaming remote console feed to our labs back at the mothership. Oh, I should clear that. Yeah, we don't want to see that. We don't want to see that either. Okay, so the first thing I want to do is bring up the Vsphere client. So this is a VM. It's a Vcenter Server. It is currently fault tolerance protected. It is a 4 vCPU VM. It's got 16 gigabytes of memory. So, you know, it's doing its thing. And here's its IP address. So I'm going to log into that server here. There it is. I'm using the Vsphere Web Client. Okay. I'm going to click over here, see what's going on there. Got one data center it's managing. Going to click on to that. Yeah, that's what I want to do. And then I go to the virtual machines. I got about 100 hosts in this data center and about 1,000 virtual machines, okay? So I'm going to click on that. And I'm just a regular user. I do things like power on virtual machines. I think I clicked that, yeah. So that spawns off a task. It continues asynchronously. While that's going on, I'll maybe power on another virtual machine. There we go. I will power on another virtual machine. There we go. Okay. No one claimed the Vsphere Web Client was the fastest thing in the world. Okay, so regular user using the machine. Let's take a look behind the curtain a little bit. I'm going to go to 2 PuTTY consoles. These are SSH'd into the Esx hosts that are running the primary and secondary. So I'm going to run a little program, Esx top on both. That's a pretty useful program. I'm looking at the CPU here, and I can see, yeah, we have 2 VMs, VMware vCenter. This one's the primary. This one, which is supposed to be a dark blue, yeah, at the bottom, that's acting as a secondary. That's the replica. Okay, one neat thing about Esx top is I can look at the network stats. Let me do that, and let me actually highlight. Learn a new thing about Esx top every day. So you can actually see that this column here represents the megabits used over the FT logging network. We're using currently 40 megabits of data across that network, and that traffic is providing the replication for this VM. Now, a little game, so it's not doing a whole lot right now, 100 megabits. A little game I like to play is to see if I can get that to bump up. So maybe I'll try doing a largish operation. I'll boot up a bunch of VMs. We gotta switch over quickly. See that? Jeez. Oh, jeez. Missed it. All right, there it goes. 1.2 gigabits, and then it dies down again. So it's doing its thing. It's using the bandwidth. We're rolling along. I'm just a regular user of the thing, and then somebody comes along, does something they really shouldn't do, and then we'll see what happens. Now, before I press enter here, I just want to note that this is a prototype. It's not a released product, and so anything can and could happen. In fact, goodness knows I've seen it all. I've seen it all. But I should say one of the reasons we're doing this live demo is because we've actually put it through much tougher paces back in Palo Alto, and so I'm very, very confident this will turn out 100% okay. Okay, so I'm going to press enter here. Now, should have rebooted by now. Oh, there we go. Putty says, server unexpectedly closed network connection. So the Esx host now gone. Usually that's when the help tickets start pouring in. Let's see what happens if I switch over to Firefox. So I'm down here. I got this VM that's powered off. I wonder, maybe I want to power that one on. Well, look, it goes on. It's continuing to execute. Things are doing mostly as I would have expected it to. And then let's say I want to power off a VM. Well, that's as simple as clicking that little box there. Yes, I actually want to do that. And there it goes. So as a user, there we are. So as a user, completely oblivious to the fact that the Esx host that was running the primary VM is now gone. Vsphere has automatically switched over to the replica that was backing that VM up. So I'm going to switch to the Putty client, and we can see it's happily running on the server that was acting as the backup. And the client of that VM, completely oblivious to the operation. Okay, let me switch back there. So that was the live failover. We saw that we got continuous availability through server failure. And it was all pretty transparent. The other thing I want to show you, let me switch back here, is I want to go over to another virtual machine that I have protected with fault tolerance here. That's this guy. It's a Red Hat VM. Nothing particularly interesting about it. It's protected with fault tolerance. Now, one thing, if you've ever used FT in vSphere today, you might have noticed was if you go to take a snapshot, you can't. It's grayed out. You can't back up your VM. People complain about that because they want to use FT to get continuous availability, but once they do that, they give up now the ability to take a backup of the VM, and that's obviously no good. And so that's a problem for people. I'm looking at the snapshot manager. I took a snapshot earlier. Of course, with this prototype, we thought this was a pretty important thing to try to deal with. So what we did was we built support for a new API, well, not a new API, an existing API that we call the vStorage APIs for data protection, or VADP. This is a public API for creating non-disruptive snapshots of a VM. By non-disruptive, I mean when you take the snapshot, vSphere will take a coherent image of the VM, save it to disk, and while that's running, the VM continues to execute completely oblivious to the fact that you're taking a snapshot of it. So this can be initiated with this VADP API. It's as simple as taking a script or a third-party program. It talks the VADP API to your data center, and it can tell a particular VM, hey, I want this VM to be saved to disk. All right? So let me show you. So we've implemented this. Seems to work. Let me switch over here now. I'm gonna invoke this API and create a snapshot. I don't have a program, a nice GUI for you. What I do have is a script that I wrote, command line thing. I'm going to run that script. It's going to talk the VADP API, which is going to connect to our host, do some magical things. Take a look at the tasks here in this snapshot manager. Do that. So we see we got creating virtual machine snapshot down here. We got our VADP snapshot there. We can use that. That's our backup. Great. If I want to take another one, do that, and voila, we've got our snapshots. So I'm going to switch back here. Now, not everyone is going to want to run this little script that I have. Maybe you don't like it. Fortunately, there are many VADP solutions already out on the market that you can get. They're like GUI programs. You can schedule things. They do all the right things. They take advantage of this protocol, and lots of vendors will happily sell you products to do that. So that's taking backup to the VM. So that's sort of the live demonstration. I want to summarize by saying we sort of gone through showing you FT in action. We started off with giving you a little about principles about what you need to know before you actually start using multiprocessor FT. In fact, how the data stores are organized and how you actually use that in making selections for like Tiebreak data store, et cetera, et cetera. We showed you how you can do backups of running FT VMs, as well as how you can ensure continuous availability of multiprocessor workloads like the Vcenter Server. Of course, any multiprocessor workload would work. We have a very good solution by this time. We're pretty pleased with it. And as you could tell from the demo, the client was completely oblivious to the FT replication and synchronization and lockstepping. All of that completely under the covers. They don't have to care about it. You fail over one host, nobody knows. So we get zero downtime, zero data loss. We had a taste for the performance and bandwidth. We showed you it with Esx top. So on the vCenter workload, you got about 100 megabits, idling, and then you spike it. Maybe it goes over a gigabit. Of course, that's not the only workload we've run. We've run tons of workloads back in Palo Alto, and I'm going to give you a taste for some of the stuff we've run. So this is a performance graph. What it shows is I've selected a few workloads that we've run. These are database workloads. SQL Server, it's a big one. People ask for an Oracle database. We've run them in 2 and 4 vCPU configurations. So this is the performance that we get when we measure the same workload running the same benchmark with FT enabled and that same workload with FT not enabled. Now, if there's no overhead, you'd expect that to be 100%. Of course, nothing comes for free. There is a cost when you enable this, and that cost is measured by the amount under 100% that you get. So for the most part, we're in the 60-70% range for a lot of these workloads. Some of them come in as like maybe 50, high 50s. These are sort of analogous workloads that we published for the existing vSphere FT feature, except we added vCPUs. OK, so let me summarize. We began this session by talking a little bit about why you'd want to use fault tolerance. In particular, it's one of the only products we have that ensures continuous availability in the face of a host failure. And we showed you fault tolerance for multiprocessor VMs. And we have a good solution to actually an impressively hard problem. It required a new design, which Srinan went over. And we demonstrated that you have a very similar experience to the existing vSphere FT in sort of ease of use and just sort of magically doing everything for you, except more vCPUs. OK? And so that brings us to the end. We'll be happy to take questions. We can take them as you shout them out. There's also mics in the back here. So if you want to come up and ask on the mic, we can certainly do that. So we have one gentleman up here. Latency. So, OK, all right. The question's about latency requirements. There are no latency requirements for the FT logging network. There is a latency that's imposed on the workload when you enable FT. So that if you're doing a ping on your workload, for example, those pings might get slower when you've enabled FT. How that affects your application is going to be application specific, whether it's latency sensitive, et cetera. But for us as a user of the network, we are not as latency sensitive. It's more about bandwidth for us. Yeah.
So you said you should be on 2 different hosts. So that obviously says you've got to turn on DRS and so that takes out some of the HA functionality.
So the question is about interaction with FT, DRS, and HA. So actually, a requirement of enabling FT is that you have an HA cluster and they have HA running, because actually it's HA that's responsible for restarting the VMs once an FT failover has occurred. So HA still works, and it's actually a requirement for it to keep running. Yeah, we have a question right here.
With the FT that was single processor, it required that you had the HA, you had DRS, and would move those workloads around. We could pre-position where the our first host, the primary, does
Yes.
it automatically do the same thing as what the single processor did, where it spins up a new shadow copy?
Yeah. So the question is about restarting FT once a failover happens. Does it happen automatically? And the question is yes. The answer is yes. When a failover happens, now you're unprotected, and it will be the job of HA to then find a new host in your cluster. It will automatically do that, and you won't have to reselect anything or do anything like that.
What about those data stores, though?
The question is about the data stores. So you've separated out the data stores. What we've talked about is host failure so far. We haven't talked about data store failure. So in case of a data store failure, you'll have, if you've chosen to, you could have replicated data stores, and so you'll still have a data store available to you. If the data store is gone, the data store is gone. So then, you know, we have a question right here.
Another question about the data stores. Is SDRS, or I'm guessing there's not now, but are plans in the future to make SDRS multiprocessor FT for where so it keeps when it moves disks around the printer?
Yeah, so the question is about SDRS and how that relates to FT. The prototype that we described today, we didn't demonstrate SDRS functionality. Obviously, we think that's important. And if you think that's important, also, it would be good to make that known to everybody you can talk to. But yes, that's an important piece of functionality. Let's go to somewhere else in the room. Okay, we get someone pointing over there.
Once you have your secondary VM spun up,
Yeah.
what's to prevent DRS from moving into the same host as the primary?
Okay, the question is about DRS and how it interacts with FT in particular, whether it makes a stupid decision to put the primary and secondary on the same host. You want to take that one?
So there is HA or DRS has this anti-affinity rule, which makes sure that your two primary and secondary VMs won't ever exist on the same physical host. And that's even today. Sorry? The anti-affinity rule is there even today with uniprocessor FT, and that will probably just continue with, I mean, HA or DRS doesn't care if it's one VCP or multi-VCP, right?
Let's take a question from the left here.
Have you been able to relax the requirement of reserving all the CPU and memory for the VMs?
So the question is, have we relaxed the reservation requirements for FT? The answer is, in this prototype, we have not. So an important consideration, just like in HA, is when you have a replica, or even when you have, you know, a failover spot on some other host, you need the resources that are implied by that replica. So you have two different VMs. They behave like two different VMs. They need, you know, essentially two copies of the VM memory, et cetera. And so that is still the case. Let's take one on the right here. That's you. Yeah.
Right, you're right, my left.
Yeah, my right. Sorry.
Well, one of the issues we've seen in the past is that as soon as you apply a patch, even though you an OS patch, you apply it to an assessment environment works, but when you do it to your primary, as soon as it takes it, just sort of go down right to there, it in the blue screen and it just rotates right across.
Yeah.
So, and what I'm seeing, I mean, take a third-party app like Semantic or whatever, to take a backup prior, but it's a lot easier just to be able to just take a snapshot and then go ahead and apply it and revert back.
Yep.
So, where a lot of that?
Yeah, so the question is about, let's see, upgrading software in an FT-protected VM and being able to take snapshots to sort of back up the state before going on to doing the update. And we showed you backup, disk-based backup solutions. Obviously, we think that is an important feature as well. We didn't demonstrate that today, but we definitely think that's important. I should also say that HA also has some is also considering, update-related features and such. And so that's also an important area, even in the non-FT realm.
And the reason I say that is because, an alternative we have, like SQL would be clustering. And if you went to that presentation, that's not an option. So I think in FT, you want to go ahead and just do it, like I said, right-click, take snapshot.
Yeah.
A minute, you do about half an hour to an hour without having to go to our third-party backup solution.
Oh, right.
Take a backup.
Yeah.
And then, depending on what it is, especially a full backup,
Yeah, yeah.
big database, take hours.
Oh, yeah. Snapshots are definitely important. We know that. And actually, you know, again, like the other thing, for these kinds of things, if you think it's important, it's good to like sort of be very vocal about that. So let's get in the back. Yeah.
If I configured or when the secondary is created, a full copy of the primary VMDKs are created in different data stores. If I have a failure of the primary, and the host primary is on whatever, and it spins up another secondary, does it in fact go through the whole process of copying all those VMDKs again?
Yeah. So that's a very astute observation. So the question is basically if I have a replicated storage, which is what we demonstrated, and one of the VMs goes down, when we reestablish protection by creating a new secondary, you know, what is the state of disk, and do we have to do the whole synchronization again? And the answer is fundamentally yes. Every time you start FT, the disks need to be in sync. Because there's a whole new copy of the VM, that whole new copy needs to be an exact copy. It can't be in an indeterminate state. So that is true. So yes. That's all I will say about that, unfortunately. You know, how much you're willing to wait for that operation is a different question, and what we can do to make that faster is a different question.
Yes.
But what's that? Yes. We've definitely hear you on that, and we agree that is a fundamentally important thing to do. Yeah, let's take it in the front. When? Okay, question is when. We have been explicitly prohibited from discussing when or even if, and so we cannot comment on that, unfortunately. We've been prohibited from doing that.
Was that binary code in your plain?
If there was a way to communicate that to you, I would have.
Can we take that up with Bogomil?
Yes.
Sure.
Yes, you can. If
Yes.
you want to talk to Bogomil, you go right ahead.
Okay, already did.
Okay.
Cool.
Right. If anyone could say something, it would be him. Yeah.
Are we going to be able to integrate FT with tagging and DRS validity rules to keep it across chassis and across data centers in a microcluster situation?
Okay, so the question is combining FT with DRS, tagging, and affinity rules to keep the replicas in certain areas of your data center. The current prototype doesn't have that, but obviously that's awesome. Yeah, let's take one over here.
That witness disk, the
Yeah.
tiebreaker, does that really create a single point of failure for the solution? Or, I mean, it's just there for the split break.
Yeah.
But
Yeah. So the question is about the tiebreak data store, and does that create a single point of failure for the system? And it's very important because it serves in the split brain role. And so if it doesn't exist, if it were to go down, then it couldn't serve the function in the split brain situation, and then you would be in trouble. It would basically be like we have basically two redundant modes of communication, and if both of them went down, then you would be in a pickle. So there are things you could do. You can imagine doing things like that, and HA does some of this where you have more than two. You have more things. There are ways you could deal with that. We'll see how that goes.
you create two disks on both sides, and then as long as one of them is available.
Yeah, exactly. So the question is, could you create more than one sort of tiebreak thing? And the answer is yes, we could. And so it's just a function of engineering, really, is all it is. Let's go back.
The only issue I have with FT is that it's expensive for host space, not for application space.
Yeah,
Yes.
right.
Yes.
Yeah,
I'm getting the word.
that's right.
Yes.
So
The
yeah.
application HA has some kind of solution, but not a complete solution to perhaps allow you to move the process as part of the
Oh, maybe you should take that. Let me repeat the question, though. The question is, FT protects against host failures. It doesn't protect against in-guest, like application failures, because those get replicated. App HA addresses some of that,
Yes.
but is not perfect. So you want to continue that?
So yeah, once again, the prototype that we have right now, we are focusing on host level failures. So can we do something to make it aware of applications and also look for application level failures? Maybe yes, but I don't know.
Well, okay. Let's put it another way. AppHA tries to solve this problem. If there are obviously aware of limitations in AppHA. Again, FT isn't the only solution you're going to be deploying, so you're obviously going to use other things like AppHA or application monitoring and so forth to make sure you have availability for the thing. So
yeah.
All these things work together as a cohesive thing. If there are gaps in it, I think that's one of those kinds of things where it's a solution that maybe both us and AppHA would work together to try to bridge. But it's obviously a difficult problem for all the kinds of different application failures you could have. Yeah.
Without getting into if or when.
Yeah. Right.
Can you talk about, obviously you have this working
Yep.
kind of. Can you
Yep.
talk about what some of the challenges or roadblocks still are? Is it still like a network overhead?
Okay, yeah. So the question is, without saying if or when, what are the current challenges with the current prototype? And I would say that fundamentally, we are very happy with the solution that we have in our labs. So the remaining roadblocks or challenges would be at just a very sort of engineering level. It's Yeah, so the question was, is it a QA thing or is it like fundamentally you need to reduce the bandwidth beyond a certain level? Actually, we showed you the bandwidth for this prototype. We've run it against a variety of other workloads. We're quite pleased with where it's at. So there's no fundamental technical limitation that we're looking at.
Can you comment too? I know you were running other swing bench workloads or old benchmarks.
Yep.
What kind of bandwidth are we looking at in that scenario? I know last year in this preview it was a very high number, right?
It was higher, yeah, that's for sure. Yeah. So we've run it in a lot of different workloads. We think it's going to have a profile somewhere in between what we've seen today and then what we saw perhaps last year. We think this will be typical. In sort of an idle situation, it will be very low bandwidth, practically take no bandwidth. In a situation where you get a spike of activity, that's when you're going to need that bandwidth. And so we saw here it's like 1 point whatever gigabits. Of course, we can give you workloads that take zero bandwidth all the time, and we can also give you workloads that peg the amount of bandwidth. But those are both synthetic, and we think what we saw today will be kind of in the range. Let's see, we got you. Questions about RDM. Questions about running FT with RDM. Do you want to take that?
Yeah, I think, so even the current FT solution doesn't support physical RDMs. We do support virtual RDMs. I don't know, but I don't think, so for this prototype, I think it might be, I don't think we've tried this, but the story could be similar. We can't use physical RDMs simply because you do realize that you'd want them to be, yeah, exactly. So virtual RDMs might just work. So on this prototype right now, I don't think we've tested it. Yes.
Yeah, in the front.
You tried this with the new Vsphere 5, we can have, 64 vCPUs. You tried anything with massive VMs?
Yeah, the question is about how have we tried it with 64 vCPUs or massive VMs? It's an interesting question. If you build like a car or something, you feel like the first thing you would do is slam your foot on the accelerator to see how fast it goes. We've done a little bit of that. We actually haven't done that. So we haven't actually tried like 64 vCPUs or anything. I will say this though, there's no fundamental limitation to the prototype I showed you today about the number of vCPUs. So 2, 4, 8, 16, 32, 64, it all handles it the same way. So really then the question just becomes one of bandwidth and then resources and that kind of thing. So we've done 2 and 4. They work just fine as far as we can tell. We've also done 8, also works, and we haven't gone beyond that. But like I said, there's no fundamental limitation on that.
So as part of this, the technical challenge, the vetting of that of the hardware, both on the CPU host side and also the network side, and is that because it's really going to be waiting upon going through the whole hardware compatibility list placement? I mean, it's kind of, to me, it's much like what we had to do and we had to wait for the Metro storage clusters. Yeah, so the question is, are we waiting for a hardware vetting and validation and so forth? I would say that we're obviously going to do that. That isn't going to be a major hurdle for us, I think. I mean, our goal is to be as transparent and compatible to the commodity hardware that you have running in your data center, and we're not imposing any special restrictions on compatibility or anything like that. So we will need to do validation, of course, but it'll be just sort of the standard validation that we do even with Uniprocessor FT and so forth. The question here.
I noticed that as the numbers of VCPs increase, that the overhead
Yeah.
increase as well.
Yeah.
Is that due to overhead in the hypervisor, or is that a function of how much network bandwidth is available? It's probably a combination of both. But what's the more difficult engineering challenge? And then at what point currently is your performance cut off not worth it anymore? Because
Yeah.
25% loss in a 4 VM of your database.
Right, yeah. So the question is, the performance degrades as you add the number of vCPUs, or at least apparently that was the case with the numbers I showed you. So what was the conclusion there?
So
Does it degrade due to
What's the reason? What's the reason for the degradation? What we've seen is the amount of work that the VM does is proportional to the number of vCPUs that you have for a parallelizable workload, obviously.
Yeah.
You can run any single-threaded application you want and you add vCPUs and it's not going to do any extra work. But typically, the reason you have a N-way VM is you're going to have a parallelizable workload. So it actually does N times more work. So if you have 4 vCPU VM and an 8 vCPU VM, if you have a workload that actually saturates it, it will do twice the amount of work. And so that will get reflected in the overhead. The more work the VM does, you have finite resources, right? So you have the same network, you have the same CPU, you have the same memory. You're not doubling that as you double the workload, so then the performance starts to degrade. So that does happen on the left. So the question is, with an FT-protected VM with SRIOV, and I think the answer is we do not support that currently.
I don't know.
I think that's not even supported for Uniprocessor FT.
is it?
That's my guess. But yeah, well, anyway, we can double check that. Are we going to be able to enable FT on powered on virtual machines? I would have loved to have demoed that for you because the prototype that we have is capable of that.
Yes.
Yeah, spontaneous applause in the back.
So whenever we have the host as the primary web client, and if it fails, the secondary comes back and initiates a new secondary. That those boots up, the original one that failed, is that VM will still exist, and so it's orphaned, I guess. Is it going to clean up after itself? Is it going to boot up and have duplicate IPs on the network?
Yeah, so what happens during a failover to the VM that lost in the split brain situation? So what happens to that VM is it actually kills itself. So the VM that loses in the split brain situation stops running because it's not safe to run anymore. Because it stops running, it's safe to then restart that VM somewhere else. And so we take care of that. In the middle? Yeah.
How many simultaneous FT relationships can you have on a host?
How many FT relationships can you have on a simultaneous FT
On a host. Okay.
VMs on a host? So the current vSphere FT, I believe, has a soft restriction of 4 FT VMs on one host. For this prototype, we obviously probably wouldn't exceed that. You know, we wouldn't now give you 8 or whatever because you're doing a lot more work for a given VM. But you know, that's probably order of magnitude in the right ballpark. Let's go on the far right or far left there.
Is it possible to get a copy of your script that bypass?
Can I get that VADP script so I can take snapshots of running FT VMs? Unfortunately, this only runs on our prototype multiprocessor FT VM. It won't work on uniprocessor FT VMs, unfortunately. That's the breaks. Yeah.
Have you seen any difference between Intel or AMD in terms of throughput?
Have we seen differences between AMD and Intel with respect to the prototype? Intel, I mean, this is just in general. Intel machines are just faster, we've seen, than AMD machines. That just in general, they're faster. And that is actually no different for our system as well. It's just in general faster. It's just a better platform. But there are several technical differences between the two platforms, which I won't get into.
Any plans to support vCPU hot end?
The question is, any plans to support vCPU hot end? This prototype definitely does not support vCPU hot end. However, there's no fundamental reason why it can't. Yeah. Yeah, in the back. Yeah. Yeah. So the question is, when you have a workload that's FT protected and needs to talk to a database, and that workload gets respun, it will have to reconnect to the database. Is that accurate? Yeah. Yeah. So that should be no problem. Actually, it should be no different than me, the Vsphere Web Client, seeing that there's a seamless transition from the Vcenter Server to another host. Likewise, a VM that was using a database, if that VM crashed and restarted somewhere else, it would seamlessly transition all the connections, all the TCP connections it would had. It actually would lose no data, and none of the TCP connections would close. It wouldn't even realize that a failover had occurred. So it would all be complete. It's just like very similar to vMotion. If you vMotion a VM from one host to another, if you were doing work on that VM, nobody would know because it transitions the TCP and everything works. In a similar way, TCP connections are retained in our situation. It's all fine.
So just one more thing, the VM doesn't have to, after an FT failover, the VM that goes live won't have to establish a new connection with the database. It'll just be there.
Its existing connection that I already made
Exactly.
will continue running. It doesn't have to make any new ones. Way in the back. Yeah. So the question is, can we, for the FT logging network, can we have multiple NICs, maybe even more than 10 gigs by having more? That's obviously something we think is important. We didn't demonstrate it today. There's, again, no fundamental technical reason why we couldn't do that. It should actually be pretty easy to do because we already have ways of grouping NICs and stuff together, so it shouldn't be a problem.
I suppose that once this does come out, it will replace the current Lockstep technology to shape retrieval CPU.
That's your supposition, yes.
So is there going to also be replaced in other ports which originally used Lockstep?
Such as?
So, yeah.
It came from
Oh.
Sure.
So, okay, so will this technology replace the Lockstep technology in all VMware's product lines? So I'm not sure if you're actually aware, but I think this has already been done, yeah.
Yes.
So vLockstep is actually using what's called record replay, which is a technology, as you mentioned, that's available in Workstation. I think the new version of Workstation has already removed the record replay functionality. So that technology doesn't exist in
Today's Workstation.
Yeah, in any VMware product except as it's used in FT. Yeah, and if your supposition holds, then even that one wouldn't exist, but no comment on that. Yeah, right here.
So if you had a wish list from the CPU manufacturers
Yeah,
to make this work better,
right.
what would you wish for?
What is our wish list for CPU manufacturers to make this work better? Obviously, more bandwidth in terms of everything. I/O bandwidth, memory bandwidth, CPU cores. And so we actually, one of the nice things is that we don't need like super special like secret technology to get this working. We just need the same stuff everyone else needs.
Yeah.
More compute power, and then we can do that. There are magical things you could dream up. Unfortunately, I cannot get into some of those magical things.
The graph you showed with the efficiency, getting close to 80%.
Yeah.
Workload, that's pretty impressive given that's like 21 VMs. Is there any theoretical limits to how far you can potentially?
Yeah, so the question is about the performance. We showed 80%, and it was pretty impressive. And is there a theoretical limit to actually? It's going to be dependent on the workload. And so right now, we have workloads where we can probably show a 90% performance, and even non-synthetic ones. So there's no fundamental limitation to how well it will perform. Practically speaking, as exists for the workloads that you're going to use under the normal running circumstances you have, it's hard to say how it'll perform, but there's no fundamental limitation to the performance. Do you want to add something to that?
No, that's
okay. Yeah, in the hat.
No question. I just wanted to say thanks for working on it. Whatever it actually is, we're going to make my life a lot easier.
No question. Just want to thank us for our hard work. We did not plant this individual. Any other questions? I see we're done. Okay, thank you very much.
Thank you.
Thank you for staying.